Welcome back to ATO Audio. Today on the channel, as you can tell from the title, I'm a little frustrated with myself, and I'm going to tell you why today. I think it's important that I not only highlight the things that go right on this channel, but also talk about the things that go wrong. And I definitely had some things go wrong on this repair. And so what you see on the bench is the Pioneer SX-890. This is the European version of the 880. And because of that, it's a lot rarer to find in the States. I actually had to look for this one for quite some time before I found one in a good shape. And it was funny, as soon as I found one, there was another one that came up for sale. So I actually got 2 or 3 of these in the shop right now. Some of the lower ones, the 590, 690, and the 790 are a little bit easier to come by, but still kind of rare. So it's a real treat when I get one of these in the shop. This one came into me and it wasn't working, and so I was eager to get it on the bench because it wasn't such great cosmetic condition and figure out what was wrong with it. And so from there, I plugged it in, didn't get the relay click, but I noticed my dim bulb on my dim bulb tester was brightly lit, and so I knew something was wrong. So I want to share with you guys some of my frustrations in fixing this and then explain what I did to finally get it fixed. So why don't you guys come in closer and we'll go ahead and get started. Okay, so here we have the unit flipped upside down, and you guys can see it's the back of the board, so we can see all the traces, the solder points, and our output transistors. And so like I said previously, when I put this up, I didn't get a relay click and my dim bulb was lit. So I knew I had a short somewhere. So the very first thing I did, anytime I know I have a short, most people don't have a dim bulb tester, so they plug it in and it could trip one of these fuses. So I just went ahead and made sure all my fuses were good and checked for continuity. They were all good, and I expected them to be good because I was still getting the short. If one of these had popped, I wouldn't be getting the bright light, and probably the unit may not have turned on as well. So the next thing I did is I went ahead and checked my output transistors. And so we have my right channel here and my left channel over here. And so I went ahead and unsoldered all my output transistors. Unfortunately, to test your transistors, you have to remove them out of the circuit, so I had to unsolder them all. Once I did that, I grabbed my Peak Atlas DCA 55 and I checked all my output transistors. And every single one of them were good. So I knew my short wasn't coming from the output transistors. And ironically, I've never actually had one of these go bad. And so at all the units that I've worked on in the past, if I've had a short or I've had a problem, the output transistors were all good. And so I think these are pretty stout. If someone else has a personal experience with these being bad or some experience with that, please feel free to share it in the comments down below. I'd love to hear it. So then I was like, okay, well, it's not coming from the output transistors, so now I need to dig a little bit deeper. And so one of the tricks that I learned, and I think I learned this from my dad, so shout out to Dad out there. My dad was an aircraft electrician in the Air Force, and so he has a lot of good information sometimes, and I think this trick was one that he taught me, or he had told me about when I was telling him about a frustration working on a previous project. And so what I started to do is I would solder in one output transistor and see if I got a short. So I soldered in this first one, no short. Soldered in the second one, no short. Soldered in the third one, no short. When I went in to solder this last one, I decided to solder one leg at a time. And so I soldered in the first leg, no short. I soldered in the second leg, no short. I soldered in the third leg and no short. And this is where I made what I would say my critical mistake and what led me down a road of frustration. Is instead of stopping there, getting my multimeter out and checking for voltages or stepping back and thinking about it, I decided, well, I know it's on this leg, I'm just going to chase that circuit. And so what I started to do was I'll follow the traces, I check that component. Go to the next component. And I did that, and all it did was lead me in a big loop around the left side of the channel, left side of the board here, or left channel, right side of the board, checking a whole bunch of components. And guess what? At the end of it, I still didn't know what the heck was causing a short. And so I must have tested 20 different components on this side of the board. Now the good news is everything tested good. Everything was well within spec, so I got a lot of good components on the board. Bad thing is I didn't find out what was wrong with it. And all I did was cause myself some frustration, and it's all because I didn't take the time to think about what I was doing. Added to my frustration was anytime that I work on a unit, if I noticed that when I work on them that there's a common problem or something that I'm seeing, I usually write down what I found was wrong with that unit. That way, if I ever work on another one, I can refer back to my notes and use those to determine or check those things first that I've experienced or run into, just to kind of speed up the process and make myself more efficient. And I had left myself good notes in the past. And so I'm going to try to show you guys this. Let me focus that a little bit better. But if you notice on here, I have a thing down here named Common Problems. And it lists 4 different resistors that are known to go bad on this unit. And so we were concerned with the left channel, so that would really be Q9. So really I can narrow that down even further to just 2 resistors. But did I look at this? No, I just kept going on my shotgun approach. And because I kept going on my shotgun approach, all I wanted to do was get frustrated and not find the problem. So I think it's a good rule of thumb to use your brain. You know, don't just start shotgunning things and taking a whole bunch of components out, because really all you're doing is hoping you get lucky and pick out the right component. When you guys open these up, you'll see that we got hundreds of resistors and transistors and diodes and everything else. So the fact that I thought that I was just going to follow this circuit and find the problem was probably a joke, and I probably shouldn't have done that. But I thought that I knew better, and so I didn't follow my notes. Now the frustrating thing was that took me half a day. So I followed that rabbit hole for half a day, got frustrated, and walked away. So the other thing, guys, is when you get frustrated, just walk away from it, come back another day when you're thinking clearly, and then reevaluate. And so that's what I did today. Came back to this, got my multimeter out, started checking voltages. I quickly narrowed in on Q25, saw that I wasn't getting the right voltages there. So I checked each leg. I found out that the collector leg was fine. That voltage looked good. Followed it back to the base. Followed that back to Q9, and I got some funky voltages on Q9. Followed those for the emitter and the collector, realized that it wasn't those 2 legs, so something had to be going on with the base leg. And I followed that over, and look and behold, one of those resistors that I had already previously written down, telling myself, go check this resistor, was right there off the leg of the base on that Q9 transistor. So guess what? I unsoldered it. And instead of it testing at 390 ohms like it should have, it was testing, I think, either 20K or 22K. And so I went and I swapped it out for a new one, and guess what? Everything works. So plugged it in, no short anymore, stereo works perfectly. So I could have saved myself half a day's worth of time if I would have just used my brain and followed common sense, used my multimeter, strategized a little bit, and just followed the notes that I left for myself where I'd previously done one of these units. So I think it's important that when I do this work, I don't just tell you about the times that I succeed and how great life is and I did everything right and whatnot. I think we learn the most from our mistakes, and I want you guys to learn from my mistake. And so don't take the shotgun approach. Get your multimeter out and start checking voltages and see if you can narrow it down. Because once I did that, I had this thing done in 20 minutes. And so if I'd have done that the first day, I could have been much more productive on my day off and moved on to another stereo, building another case, you know, trimming my fingernails, who knows? Could have done anything with that time. But instead, I went down the rabbit hole trying to do a shotgun approach. So let this be a lesson to you. Don't be dumb like me. Use your brains. And if you need to, walk away from it and come back another day with a fresh set. You know, I think there's something about sleeping on things where your mind is fixing problems in the background. And I think there's a lot to be said for that. So I hope you got something out of this video, whether it's just I'm human and I make mistakes too, or to let you have the confidence to track down problems and use your multimeter. And ultimately, the best tool you got is using your brain. So thanks for watching, and I'll see you guys on the next video.